For years, there's been this one big myth hanging over one of the coolest pieces of tech to come out in a decade, the foldable phone. And the story was always the same. They're fragile. Cool concept, sure, but at the end of the day, a serious engineering compromise. Well, today, we're going to absolutely shatter that myth. We're diving deep into the science that makes these screens practically unbreakable.
And I mean, this was the reputation, right? The early reviews, the first-hand accounts, they all seem to point to this. The idea of a screen that could literally bend in half was amazing, but everyone just kind of accepted it came with a catch. You'd get that ugly crease, the layers might start peeling apart, or the whole thing would just give up after a few months. It felt like that was just the price you had to pay.
But what if I told you the trade-off is gone? That the latest folding screens are now certified to handle this many folds, 500,000. And no, that's not a typo. To put that in perspective for you, if you open and closed your phone 130 times every single day, it would still last you for over a decade. This isn't just a small improvement, it's a complete revolution.
So how on earth is this even possible? Well, we're going to bust that fragile foldable myth wide open. Then we'll uncover the 3 big secrets that made it happen: some incredible ultra-thin glass, a clever physics trick called the neutral plane, and a way smarter hinge. And finally, we'll get into why this changes absolutely everything for the future of our devices.
So, the big question is, how did we get here? How did we go from handle with care to basically indestructible? Well, it wasn't some lucky accident or a minor tweak. This massive leap forward came from some really fundamental breakthroughs in both material science and engineering, turning these phones from fragile curiosities into true marvels.
Okay, let's pull back the curtain on secret number 1. And it all starts with a material that honestly sounds like it's straight out of science fiction. Ultra-thin glass, or UTG for short. This stuff is the absolute foundation, the key that lets a screen be ridiculously flexible without shattering into a million pieces.
And making glass that can actually bend is this fascinating 2-step dance. First, a process called fusion drawing creates these perfectly flawless sheets of glass that are only 30 to 50 micrometers thick. I mean, we're talking thinner than a human hair. But, being thin is one thing. It also has to be strong. That's step 2, chemical strengthening. The glass literally takes a bath in molten potassium nitrate, which forces a kind of ion swap on the surface to create this incredibly tough, resilient outer layer. The science behind that strength is what's truly mind-bending. It's a state called compressive pre-stress. And this atomic level armor analogy, it's perfect. You're basically creating this super compressed surface layer that actively fights back against the tension that causes cracks when you bend something. It's like building armor right into the glass to protect it from the physics of folding. All right, so we've got this impossibly strong, flexible glass. Awesome. But what about the actual display parts? The really delicate organic layers that light up and create the image you see. Well, that brings us to secret number 2, which is this brilliant bit of engineering physics called the neutral plane. It's all about designing the perfect stress-free fold. Okay, this explains it perfectly. Think about it. When you bend anything, a piece of paper, a book, whatever, the outside edge has to stretch, and the inside edge gets compressed or squished together. But there's this magical line right in the middle, the neutral plane, where there is zero stress. It's not being stretched or compressed. So what did the engineers do? They cleverly placed the most fragile parts of the screen, the OLEDs, exactly on that line. So while other layers are feeling the strain, the all-important parts that make the picture are perfectly safe. It's genius.
So we have insanely strong glass and a cleverly protected display stack. But how do you actually fold the thing without creating one giant weak point right at the crease? That leads us to secret number 3, the hinge. And let me tell you, this is so much more than a simple joint. It's a really intelligent, active stress management system.
Yeah, these modern hinges are basically active bodyguards for the screen. They use these tiny micro gears to dynamically change the shape of the fold as it happens, which spreads the stress out over a wider area instead of focusing it on one sharp point. But the really brilliant part is how they manage the screen's different layers. They actually allow for tiny controlled bits of slippage between them. Think about how the pages of a thick book shift when you bend it. It's like that. This tiny movement stops the layers from tearing each other apart over time, which is a big problem called delamination. And the level of precision we're talking about here is just staggering. These incredibly complex hinge systems keep the two halves of the display aligned to within 30 micrometers. Let me be clear, that is less than the width of a single human hair.
It's a mind-boggling feat of microengineering that happens every single time you open or close your phone.
But hey, how do we know all this complex tech actually works in the real world? Well, that's where this comes in. Absolutely brutal, standardized testing. This isn't just marketing talk. Independent labs put these phones through an absolute torture chamber to validate these claims. We're talking 500,000 folds, wild temperature swings from freezing to boiling, crazy high humidity, and intense vibrations. And they have to pass all of it to earn that durability certification.
So, you've got these 3 huge breakthroughs all working together, and they're verified by some of the most intense testing imaginable. The result is a truly durable foldable screen. But so what? What does that actually mean? Why does making a phone that doesn't break when you fold it change the entire game?
Well, solving this durability problem unlocks a whole new era for our gadgets. First up, you get device convergence. Just imagine one device in your pocket that can seamlessly unfold into a big tablet for work or watching movies. Then there's enhanced reliability. These aren't just delicate toys anymore. They are tough enough to be your main phone, your daily driver. That in turn leads to improved sustainability, because a device that can last for a decade means a lot less e-waste. And finally, it all fuels industry innovation, pushing the entire field forward in everything from glass science to advanced metal alloys.
So there you have it. The fragile foldable, yeah, that's officially a myth, totally busted by some really incredible science. Thanks to atomic-level engineering, clever physics, and some mind-blowing mechanics, these phones have become some of the most durable pieces of tech you can buy. Which leaves us with one last, really exciting question. Now that our screens are this tough, what should we fold next?